Alright, so welcome to another math tutorial. This one will be focusing on the Pythagorean Theorem, which can be seen on this corner of the screen right here. So, the Pythagorean Theorem was created by an ancient Greek philosopher and mathematician called Pythagoras, who's pictured here in a very historically accurate depiction of his likeness. And the Pythagorean Theorem was created to specifically only work with right triangles, so triangles that have a 90-degree angle in them. And it's essentially just adding the legs A and B, their squares, to get the hypotenuse, which is the longest side of the triangle. And once you finally get that result from adding those squares, square rooting the C result you get to find the actual hypotenuse. So, for example, let's say we have a right triangle here with base A of 6 and the other leg being 8. So, how would we approach this? We start by adding 6 squared plus 8 squared. This would be the same thing as saying 36 plus 64. Now, that would give us 100, which would be the result of adding the two squares together. But to get the actual hypotenuse, we'd have to find the square root of this 100, which would be 10. So, C would equal 10. Let me just write it here. Now, the Pythagorean theorem can actually be used to find the other legs instead of just the hypotenuse. So, let's look at another example here. Here, we're going to have a hypotenuse of 13. And we're going to have the leg A be 5. So here, we'll be trying to find the leg B. Now, in this case, we can simply just rearrange the Pythagorean theorem to find the intended result. So in this case, it would be C squared minus A squared equals B squared. So 13 squared minus 5 squared would be the same thing as saying 169 minus 25. Now, this would give us 144. But remember, we're not done yet. Now we'll have to square root this 144, which will give us 12. So, therefore, B is equal to 12. And that's it. That's how you can use the Pythagorean theorem to find the hypotenuse and the other legs of the right triangle.